Welcome to today's Explainer, everyone. I am absolutely thrilled you're tuning in for this one, because today we're decoding the physical anatomy of our digital future. Look, whenever we talk about the AI revolution, it is so easy to get totally caught up in the software side of things, right? The chatbots, the crazy image generators. But today we're looking beneath the screen at the unbelievably complex physical foundations that are actually making all of that possible. Semiconductors are the new oil. Honestly, let the weight of that statement sink in for a second. We really need to completely reframe how we think about this technology. Semiconductors are no longer just, mere electronic parts sitting inside our gadgets. They have evolved into the vital strategic infrastructure fueling an entire global revolution. Just as oil powered the industrial age, semiconductors are literally the raw fuel of the AI age. Okay, let's dive into this. To really grasp how this all works, we're going to map out the semiconductor supply chain like it's a connected, living system. First, we'll look at the scale of this new oil demand. Then, we'll examine the system's heart, the logic chips. From there, we'll trace the arteries where the data flows. Next, we'll see how this intelligence expands out to the edge of the nervous system. And finally, we'll look at the expanding future boundaries of all this tech.
Section 1. The tech world's new oil, fueling the generative AI boom.
The reality we are facing right now is that the depth and breadth of our digital transformation is entirely dictated by semiconductor technology. Over the last couple of years, the absolute explosion of generative AI has triggered an exponential, and I mean exponential, growth in global demand for computing power. Every single time you ask a chatbot a question, massive physical hardware is working in overdrive somewhere. Without these physical chips constantly advancing, the software simply can't scale. It can't get smarter and it can't get faster. Moving on to Section 2, the heart. Logic chips pumping raw computing power. If semiconductors are a living anatomy, high-end logic chips are definitely the heart. AI training relies heavily on pure processing efficiency, which ultimately comes down to microscopic measurements. We're talking 3 nanometers and moving rapidly toward 2 nanometers. To put that into perspective, a single strand of human DNA is about 2.5 nanometers wide. There is no way around it. We are manufacturing infrastructure at the scale of biology to support these massive, sprawling large language models. The process literally must shrink to these microscopic levels just to enhance power while lowering energy consumption. So whether we're talking about those highly sought-after NVIDIA GPUs or the custom ASICs, the application-specific integrated circuits developed in-house by major cloud service providers, they all share one absolutely crucial requirement, which is advanced microscaling. Why? Well, because these high-end chips provide the critical transistor density needed to actually run these massive LLMs in a viable time frame. Without that insane density, the computation would either take far too long to be useful, or it would burn through a completely unsustainable amount of power. The heart has to pump efficiently.
Section 3. The arteries. Data transfer, clearing the blockages for data flow.
Now, having a massive, powerful heart means absolutely nothing if the lifeblood, our data, gets blocked in the arteries. Digital transformation isn't just about calculating data. It is fundamentally about how fast that data can actually move. And that brings us to a very severe threat to the AI revolution, the memory wall. This is the performance bottleneck that's caused when traditional memory simply lacks the bandwidth to keep up with the incredibly high-speed processing of our logic chips. If the heart beats faster than the arteries can handle, the whole system chokes.
So how exactly is the industry smashing through that wall? The big breakthrough here is high bandwidth memory, or HBM, combined with advanced 3D packaging technologies like CoWoS. Instead of laying all these components out flat where data has to travel long distances, this technology stacks multiple chips with different functions vertically. It's almost like high-tech Lego blocks packed into a single, highly efficient package. This integration provides a massive, shortened pipeline for data to flow without delay. It is a real game changer and the absolute technical cornerstone, allowing modern data centers to support such massive global cloud demands.
Section 4. Expanding reach. The edge. Achieving ubiquitous intelligence.
Okay, so we've looked at the heart and the arteries inside those massive data centers. But the ultimate goal of all this digital transformation is ubiquitous intelligence. Basically, intelligence everywhere. AI is rapidly extending its reach from that heavy cloud infrastructure right out to the absolute edge of operations, like a nervous system. And out at the edge, you obviously don't want massive heat and power consumption. You need low-power, high-efficiency chips. So the crucial point is, This edge technology is what actually makes AI PCs, smart factories, and autonomous driving a reality. It allows enterprises to conduct real-time data analysis right on the front lines, optimizing things instantly without constantly pinging a distant cloud server.
Finally, Section 5, expanding AI's future boundaries, the backbone of the smart society. The innovation here is far from over. Currently, we are mastering advanced packaging like that 3D stacking we just talked about, but in the near term, we are going to see heterogeneous integration. This is where the industry will further perfect combining wildly different types of chips into seamless, unified powerhouses. And on the horizon, silicon photonics. This is an incredible technology that will eventually use actual light rather than traditional electrical signals for data transfer. It will continuously shatter AI's current limits, dramatically reducing energy consumption while vastly increasing speed. Together, these leaps in innovation literally construct the backbone of our future smart society.
Because this technology is so fundamental, we really have to recognize the pure economic and strategic reality of the situation here. Mastering chip research and development, and, crucially, controlling this incredibly complex supply chain, well, it isn't just a matter of corporate success. It is about global strategic infrastructure. Whoever controls the research and the supply of this new oil inherently holds the ultimate discourse power over the entire global digital transformation. It dictates who gets to innovate, how fast they can scale, and what the future of AI actually looks like. So who will control the ultimate discourse power of our digital future? The next time you look at your smartphone or read an article about the latest AI breakthrough, remember the microscopic heartbeat and those complex data arteries making it all happen behind the scenes. Understanding this physical anatomy is absolutely the key to understanding where our world is heading next. Thank you so much for joining me for this explainer today. Keep learning, keep questioning, and I will see you next time.